Hello. In this section, we will see how to design a spur gear. Consider this question. Design a spur gear to transmit power equal to 15 kilowatts. Teeth are of 20-degree involute. Transmission ratio 4:1 and pinion rotates at 1800 rpm, and both gears are made of casting. In a spur gear drive, there are two gears. The smaller gear is called the pinion, usually denoted with a suffix 1, and gear have a suffix 2. So diameter D1 represents diameter of the pinion and D2 represents diameter of the gear. First step is to select the material. So from page 234, table 12.7, we have to select a material. It is given cast steel. So we select 0.2% carbon cast steel, which is heat treated, and this have a static stress about 193.2 Newton per millimeter square, and its BHN value is equal to 250. Both are made of same material, so we select same material for the pinion and the gear. This completes our first step. Now we have to select which is the weaker element. Even though they are made of same material, they have different geometry, they have different dimensions. We have to select which is the weaker element. So we have to identify whether gear or the pinion, which one is the weaker element. So for that we select a value called strength factor. Strength factor equal to sigma d into y. We have already found the value sigma d equal to 193.2 Newton per mm square. Y is a new term, that's called the Lewis form factor. From page 204, we have three equations for different pressure angles, from which we can say that for 20-degree involute, value y equal to 0.154 minus 0.912 by Z, where Z stands for the number of teeth. Z is the number of teeth. We don't know the value of Z. But in order to prevent interference, it is given that from table 12.4b page 230, it is given minimum number of teeth for 20-degree involute. Minimum number of teeth. Usually, minimum number of teeth will be on the pinion. So Z1 is the minimum value, Z2 is the maximum value. Z1 equal to 18. How will you find Z2? Transmission ratio is given. Z2 by Z1 is given as 4. So Z2 equal to 72 teeth. Taking these values in the equation for y, we can find y1 equal to 0.154 minus 0.912 by, instead of Z, we substitute Z1 18. That value will come over to 0.1033. And similar value for gear, it is 0.154 912 by 72. That value will come up to 0.1413. So we have got the value of sigma y1 and y2. Now we find the strength factor, because we had to find the strength factor to find the weaker element. So sigma d1 y1 equal to 193.2 into y1 equal to 0.1033, and for gear it is 193.2, same material, 0.1413. Whichever is weaker, that will have a lower value. So we can see that sigma d1 y1 has a lower value, so pinion will be the weaker element. So our inference is that sigma d1 y1 for the pinion is lower than sigma d2 y2 for the gear is for pinion. So pinion is a weaker element. We have to design this pinion. Now we are moving to the most important step of this question, that we have to find the module. In a gear set, module will be same for both gears. In order to find the module, we have this equation from equation 12.5b. Be careful for this equation. We should be, you can rewrite this equation m cube equal to 2mt by sigma d cv k capital Y Z, where mt stands for the torque, sigma d is the static stress, that is 193.2 Newton per mm square, cv is the velocity factor, then k is given by k equal to b by m, capital Y equal to pi y, z equal to z1, because we are designing the pinion, z1 equal to 18. Now we will see one by one. First we will find mt. Mt equal to torque transmitted, mt equal to 60p by 2 pi n, 60p by 2 pi n. We are given power equal to 20 kilowatts. Power equal to 20 kilowatts. Since we have to get the unit in Newton and millimeter, 20 kilowatts equal to 20 into 10 power 6 Newton millimeter per second, and speed equal to 1800 rpm. That's the speed of the pinion. You will get mt equal to 79.58 into 10 power 3, that much Newton millimeter. So we have found the numerator in the right side of this equation. We have now the value of sigma d. Substitute cv as such, then k equal to b by m, k equal to b by m. See this equation? Now range of b by m, b equal to, from equation 12.5f, b equal to 9.5 to 12.5 m, 9.5 to 12.5 m. If you take the mean value, it is 11 m, so k equal to b by m, 11 m by m equal to 11. Then sigma d equal to 193, sigma d equal to 193.2 Newton per mm square. Then z1 equal to 18, pi y equal to pi y1, y1 equal to 0.103. We can substitute all this value. We will get m cube cv equal to, we'll substitute all these values, m cube equal to 2 into mt equal to 279.58 into 10 power 3, that is a torque mt in Newton millimeter, divided by sigma d 193.2, sigma d. Substitute cv as such, then k equal to 11, capital Y equal to pi y 0.103, this total value is capital Y, into z1 equal to 18, z1. After substituting all these values, we will get m cube cv equal to 12.81. Now we come to the most interesting step, which is how to find m. For some unknown value of module, we get m cube cv equal to 12.81. cv is called the velocity factor, for which we had to need to find the velocity. Velocity equal to our primary equation is pi d1 n1 by 60 equal to pi into diameter. We can write in terms of module m z1, so module into z1 is 18 into n1 equal to 1800 divided by 60, which comes about to 1696 m. Now we have to prepare a table. So our velocity is 1696 m. We need to get the velocity in meters per second. So we substitute module in meters. We do with trial and error method. That is trial and error method. substitute the initial module equal to 2 mm equal to 0.002 meters, 2 mm equal to 0.002 meters. We get the velocity equal to 1696 into 0.002 3.39, that much meters per second. CV can be found from page 205. We have now our equation for velocity less than 8 meter per second. CV equal to 3 by 3 plus velocity. Velocity value you substitute at 3.39. We get CV equal to 0.469 and m cube CV equal to 2 cube. In this module should be in millimeter. 2 cube into CV equal to 0.469. That value will come to 3.752. So our required value is 12.81. M cube CV equal to 12.81, but our got value is only 3.752, so it is not safe. So we go to for a higher value. We select 3 mm, that is 0.003 meters. Now velocity will be 1696 into 0.003 equal to 5.08 meters per second. See, velocity is less than 8 meters per second. We can use the same equation for CV. CV equal to 3 by 3 plus velocity equal to 5.08. That value is 0.375. And m cube CV is only 10.175. So this is also less than 12.81. It is unsafe. So we have to go to higher value. Is next. Now we check the value with 4 mm, 0.004 mm. Our velocity will be 6.78 meter per second, and CV will be equal to 3.306. And m cube CV equal to 4 cube into CV equal to 0.306 equal to 19.63, which is greater than the required value 12.81. So
here's an answer from Wikipedia.
So we have the module, standard module equal to 4 mm. After finding the module, we can find the dimensions of the pinion and the gear. We have the Z1 equal to 18, Z2 equal to 72, D1 equal to MZ1 equal to 18 into 4, and for pinion D2 equal to MZ2 equal to 4 into 72 mm. You can find all these values from the table given in page 230. After finding the dimensions, now we have to check for dynamic load and wear load. We have this equation. In this equation, Ft is the tangential load. Then K3 is given as 20.67. It is given in the data book in page 207. Is given. V is the velocity. We have already found the velocity for 4 mm, that is 6.78 meter per second. B is known. B equal to 11 m equal to 44 mm. Now we have only unknown value C. First we will find the value of Ft. Ft equal to 2 mt by d. Since we are designing the pinion, we take it as d1. 2 mt by d1 equal to 2 into 79.5 into 10 power 3 divided by d1 equal to 72 mm. That will come to 2208 Newton. then B equal to 44 mm, K3 equal to, then we can find FT plus BC. Okay, to find that we have to find the value of C. To find the value of C, we need to use a graph. From figure 12.5, for velocity equal to 6.7, velocity is given x-axis, for velocity equal to 6.78, error in action f equal small f equal to 0.053. Taking this value, error in action, in table 12.12, this 0.053 lies in between 0.04 and 0.06. That's 0.053. What is our material? Steel and steel. Both are made of steel. Pressure angle is 20 degree involute. 20 degree involute. So for 0.04 it is 457.8. For 0.06 it is 686.7. Now we do a linear interpolation. So we put it as 1, 2 and 3. 2 minus 1 by 3 minus 1. Do it in both these rows. We'll see that how we do that. 2 minus 1, 0.053 minus 0.04, it is second column minus first column divided by same one in the second row also. C minus 457.8 equal to 3 minus 1, 0.06 minus 0.04 divided by 686.7 minus 457.8. we will get C equal to 606.5 kilonewton per meter. Now we will substitute all these values. From the equation we can see that FT plus BC is a common term. So we can find first FT plus BC. FT plus BC equal to FT plus BC equal to 2208 plus B equal to 44 mm into 606. That value comes about to 606 28,872. So our value of FD equal to FT plus 2208 plus 20.67 into velocity equal to 6.78 into 28,872 divided by 20.67 into 6.78 plus root 28,872. That value comes up to into 6.78 into answer plus root 28,872. $15,257 Newton. Now we know the value of FW from equation 12.15a equal to D1BQK. D1 equal to 72 mm. That's D1. B equal to 44. Q equal to 2Z2 by Z1 plus Z2. When you substitute this value, you will get is Q equal to 2 into 72 divided by 18 plus 72. That value is come to 1.6 K. So after substituting all these values, we will find is equal to 72 into 44 into 1.6, that is 5068.8 K. Then maximum value is FD can be up to FW. So equating FD equal to FW, you get K equal to 3.009. Now from page 239, we have to select for 20-degree involute, that is the last column. For 20-degree involute, for steel and steel, select a value which is greater than 3. We see that that value start from 0.284 for 0.029, and for the third set it is ends with 2.34, and for the fourth set it starts with 3k equal to 3.226, for which the hardness values are BHN values are 450. If you are remembering the initial value was only 250 BHN. So if we heat treat the gear and the pinion material from 250 BHN to 450 BHN by using heat treatment, HT heat treatment, then we can use this value of K. Then at that time FW will be equal to, our value will be equal to 5068.8 multiplied by 3.226. That value will be equal to 16,351.9 Newton. This is the minimum load required for wear. Since our load applied is lower than that, because our FD is only 50,257. So FD, we can compare FD and FW. This new value FD is less than FW. Our dynamic load is not sufficient to produce a wear, so our design can be safe, provided we heat treat it to 450 BHN. Thus our design becomes safe. Thank you.